All right, so 1.6 notes, we are going to start with a warm-up. So go ahead and pause your video and try this piecewise function. And at any point, if you're struggling, you could always listen to me go through it. Okay, so I have 4 pieces. Let's start with this first piece. Make my table of values, x, y here. So I'm plugging in x values less than or equal to -3. So I'm going to do -3, less than -3 is -4, -5, and I could keep going. I'm going to put an arrow there. If I need to plug in more, I will, but the arrow tells me that there's going to be an arrow on the end either way. All right, plugging in -3. -3 is +3 minus 2 is 1. -4 is 4. 4 minus 2 is 2. And this is 3. And now I can graph that. So let's look here, and it says at -3, I'm going to have a closed point, and this goes on forever. And I just stopped because I wanted to see if it was enough. If it's a line, I only need 2 points to make a line, right? All right, so -3, +1, closed point, -4, 2, -5, 3, and then it keeps going on forever and ever. Okay. Next piece. This is piece number 2. All right, table of values. I'm going to plug in -3, -2, -1, 0, and 1. -3 through 1, it says. And when I go to plug those in for x, I get an automatic output of 2. So 2, 2, 2, 2. And it goes from an open point to an open point. All right, so -3, 2, open point. Then I have -2, 2, -1, 2, 0, 2, and another open point at 1, 2. So I'm going to connect those with a horizontal line. Okay, the next piece, table of values. I'm plugging in 1, 2, and 3. All right, 1 squared is 1, minus 1 is 0. 2 squared is 4, minus 1 is 3. 3 squared is 9, minus 1 is 8. Looking here, I go from an open to closed. All right, 1, 0 over 1 up 0 is open. 2, 3. 3, 8. So notice I'm making that curved because it is part of a parabola. All right, last piece. Okay, so this says plug in x values greater than 3. So I'm going to start with 3 because I need an open point there. 4, 5, 6. I'll put an arrow here in case I need more numbers. Okay, start with 3. 3 minus 3 is 0. The square root of 0 is 0. Plug in 4. 4 minus 3 is 1. The square root of 1 is 1. Plug in 5. 5 minus 3 is 2. I don't know the square root of 2. Plug in 6. I don't know the square root of 3. So I'm actually going to extend this. I'm going to plug in 7 because I want at least 3 points when making a parabola or a square root function or a cubic function. Because if I only have 2, I don't want to connect it with a straight line. All right, plugging in 7. 7 minus 3 is 4. The square root of 4 is 2. And then remember, this goes on. I erased the arrow right there. Okay, so I have 3, 0 is an open point, and then it's going to go on forever. So 3, 0, open point. 4, 1. 7, 2. And then going on forever. So this is what my piecewise function looks like. The next thing that's asked is a review of domain range, increasing, decreasing, and constant. So if you haven't done that yet, go ahead and pause the video and try that on your own. Okay, where is it increasing from left to right? The green piece is increasing, and the purple piece is increasing. But realize it's not increasing from the green to the purple, so I have to write them as separate intervals. So I'm going to say from 1, 2, 3, and then again from 3 forever. Decreasing. The blue piece is decreasing. Negative infinity to negative 3. Constant, the red piece is a constant. Negative 3 to 1. Domain and range. Start with domain. I look left. It's an arrow going on forever. Negative infinity. All right, let's see. Now the blue piece stops right here, but notice the red piece picks up vertically from it. And there's a closed point on the blue piece there, so I'm going to keep going. The red piece stops right here. The green piece picks back up, but there are no x values there. So I'm going to say that there's no x values at 1. Forgot a comma, 1. Union. But then the green piece picks back up at 1. And it keeps going. And it stops right there. But the purple piece picks up vertically from it. Now I'm not going to write that my function stops at 3 because there is a value at 3 on the green piece. So I'm going to keep going. And it goes on forever. So there's my domain. Now let's check out range. The lowest my graph goes. So looks like the lowest my graph goes is 0. And I want to check out to make sure that there's no arrows pointing downward, which there's not. So I go here, I hit that blue piece, and I realize, hey, if I'm going to follow that blue piece, it's going to go on forever. So my range, there's nothing at 0. They're all open. So 0, comma, and then forever, infinity. I'm going to make sure I erase this highlighter here. Okay, there's the warm-up. Okay, so what we are talking about today is the air quote new notes is operations of functions. So you guys have actually learned this before. And it was actually in your summer packet. So I'm going to go through it pretty quickly because it's really not difficult for you guys at all. Okay, so as a reminder, on A right here, this says add the two functions. So add f and g. B says subtract them. D says divide them. And E says also divide them. And then C over here, which I totally did not see at first, says multiply, right? Now, when we get down here, this does not mean multiply, okay? This is a composition of functions. So this is saying the same thing as find f of g of x. So take g of x and plug it into f of x. So let's start with the super easy ones. Also notice in the direction says also find the domain of each function. So it's good practice with that. That we just learned that. Okay, so this says add f and g. So here's f, here's g. I want to add them. So all that I'm doing is combining like terms. Okay, so I have 2x minus 4. And to that, I'm adding x squared minus 2x. So combine like terms since it's just addition. Write it in standard form too. So I have f plus g of x is equal to, combining like terms, writing in standard form, x squared comes first. I have a negative 2x and a positive 2x, which cancel, and then minus 4. Okay, make sure you still have a function name here, like I have f plus g of x. It says find each function. If you just put x squared minus 4, that's an expression. Domain, are there any restrictions? There's no square roots, there's no denominators, there's no restrictions. All right, next one, g of x minus f of x. So I have to do g of x, which is x squared minus 2x, and then I have to subtract f of x. So realize f of x is 2x minus 4. I have to subtract the whole thing. So don't just put minus 2x minus 4, because you'll only then subtract the 2x. Distribute your negative to subtract. And now you have g minus f of x is standard form. X squared is going to come first. Negative 2x and negative 2x is minus 4x, and then plus 4. Common mistake is putting minus 4 because you didn't subtract everything. Are there restrictions? No. So what's my domain? All real numbers. All right, next one. F of x times g of x. So f of x is 2x minus 4 times g of x, x squared minus 2x. So these are two binomials, so all that you're going to do is distribute. A lot of you like to call it foiling, which I'm absolutely fine with calling it that. So multiply these two. 2x cubed. Distribute here, which is outer, minus 4x. Distribute the negative 4 here, which is inner, negative 4x squared. Distribute the negative 4 here, which is last, which is plus 8x. Okay, so I'm going to write my final answer here. F times g of x is standard form, so the cube's going to come first, 2x cubed, minus 4x squared, and then there are like terms that I can combine. Oh, but no, there shouldn't be. Where did I make a mistake? Let's see, 2x, 2x times negative 2x is negative 4x squared. So there were like terms, but it was supposed to be those two. That's what I did. Okay. Caught my mistake before I can do it because it didn't make sense to me. Okay, so combine these two, negative 4x squared and negative 4x squared, which is negative 8x squared, and then plus 8x. Notice I didn't stop and start over because I made a little mistake, okay? And I just found another one. Minus 4x. No, I didn't. That looks good. Okay. Domain. See how I get all frazzled? But it looks fine. Okay, next is domain. Are there any restrictions? Are there any square roots? No. Are there any denominators? No. My domain, all real numbers. Okay. Next one, f divided by g. So f is 2x minus 4 divided by g, x squared minus 2x. Okay, so remember with fractions, we have to see if they're simplifiable. But before you simplify, you should find the domain first, because if it simplifies and something cancels out, you're not going to realize that that's excluded from the domain. So let's do domain first. Are there any restrictions here? Yes, there are. We have a denominator. Denominators cannot be equal to 0. So I need to solve that. It's a quadratic with an x squared and an x. First thing I ask is, can I solve by square rooting? No, because there's an x squared and an x. So I'm going to try to factor it. There's a GCF of x. So x can't be 0, x can't be 2. Think about what that looks like on a number line. Here's 0, here's 2. Can't be, can't be. Can be all this, can be all this, can be all this. So I'm going to write my domain first. Negative infinity to 0, union 0 to 2, union 2 to infinity. All right, now I'm going to go see if this is simplifiable. So if a fraction is simplifiable, you have to cancel out common factors. So it has to be factored first. So the numerator is factorable. There is a GCF. The denominator, we already know it's factorable. It's right here, x times x minus 2. And as you can see, it is simplifiable. So this simplifies to f of g of x is 2 over x. So notice if you just looked at your answer, you would forget to exclude 2 from your domain. Okay, last one, E. F divided by H. So where's F? 2x minus 4 divided by H. Square root of, that's kind of cut off there. Let me look at my answer key. What is that supposed to be? It's supposed to look like this, I think. I don't have my answer key in front of me. I'm assuming that. It doesn't matter if it's not, because that's what it is now. All right, square root of x minus 1. Okay, so now I want to see if I can simplify this. We do know how to simplify this, but there's not like it's going to cancel out any common factors, so we're going to leave our answer like this. F of h of x is, because the denominator is not factorable. Okay, are there any restrictions? Yes. There's a square root in the denominator, so I know that the argument, which is x minus 1, has to be greater than 0, so x has to be greater than 1. So now I'm going to write that as my domain, Greater than 1 would be parentheses, 1, comma, infinity. Okay. All right. So the last thing that we have to talk about, and then we're just going to do examples of that. Notice that example 1, 2, and 3 are all with compositions. Is the last thing we are going to talk about is compositions of functions. Excuse me. So the first one says, find f of g of x. That's what this says right here. Okay. So composition of a function, this is how we write it. This is how you wrote it in Algebra 2 with trig. But Algebra 2 with trig started teaching this way also 2 years ago. So you guys already know what that means. Okay. So let's go ahead and do this. Oops, I meant to erase that. This first one says find f of g of x. So first off, I like writing it like this first. Find f of g of x. So this says take the function g of x and plug it into f. So first off, I'm going to write down f of, and then I'm going to look to see what g of x is. It is x plus 2. So now I'm going to plug x plus 2 into f. So here's f. I'm going to plug in x plus 2 here. So that becomes x plus 2, and then this square minus 3. Only thing I have to do here is expand this and then combine like terms. Remember, x plus 2 squared is x plus 2 times x plus 2. And then I have minus 3. So this is x squared plus 4x plus 4 minus 3. So finally, f of g of x, notice it's not a dot, x squared plus 4x plus 1. Are there any restrictions? Nope. Domains all real numbers. All right, next one, g of f of x. So once again, I just like writing it like this to think. All right, so this is g of, and now I'm going to write down what f of x is. F of x is x squared minus 3. So now I'm going to go to g, and instead of writing x, which is right here, I'm going to write x squared minus 3. So I have x squared minus 3, and then the plus 2. So that's x squared minus 1. Once again, this is g of f of x. Are there any restrictions? Nope. All real numbers. Okay, next one. H of g of x. H of g of x. So I like writing that down first and then writing down what g of x is, which is x plus 2. So this means take h and plug in x plus 2. So here's h, plug it right here, x plus 2 instead. So I have x plus 2, but then I still have this plus 4. So that is the square root of x plus 6. And that's h of g of x. Are there any restrictions? Yes, there are. There's a square root. We know that the argument, x plus 6, has to be greater than or equal to 0. That means x has to be greater than or equal to negative 6. If you need to draw it, you can, but that would look like this, bracket negative 6, comma, infinity. And there's your domain. Okay, so example 2 and example 3 are just trying pretty much the same thing, but with different types of problems here. Okay. G of f of x. So g of, I'm going to write down what f of x is, x squared minus 3. And now I'm going to plug that into g. So that becomes 1 over, instead of writing this x right here, I'm going to write x squared minus 3. And then I have plus 2. I can combine like terms right here. So that's 1 over x squared minus 1. And this was g of f of x. Are there any restrictions? Yep, there's a denominator. Denominators can't be 0. So x squared can't be 1. Square root plus or minus, square root plus or minus. X cannot be positive or negative 1. Think about what that looks like on a number line. Here's negative 1, here's 1. Can't be that, can't be that. Can be anything smaller, anything in between, anything bigger. So my domain is negative infinity to negative 1 union, negative 1 to 1 union, 1 to infinity. All right, next one, g of f of 3. So first things, I have to find f of 3, all right? So we're going to plug 3 into f. Plug in 3 there, I got 3 squared, which is 9. 9 minus 3 is 6. So I'm going to do g of 6. Plug in 6 here. 1 over 6 plus 2. So I get 1/8. G of f of 3 is 1/8. Domain, are there any restrictions? Denominators can't be 0. Solve for x. There is no x to solve for, therefore there are no restrictions. So my domain is all real numbers. Okay. Last set here. And then this set is here so that we can talk about this last example here. Now, usually in class we had you come up with two functions that when you take f of g of x and g of f of x that they're equal. But we're going to actually skip that since we can't work in partners today. I'll do it live teaching, but it won't be on the video. We'll actually bring it up tomorrow in class with inverses. Okay, so f of x, f of x, f of, what's f of x? 1 over x. So I'm going to plug that into f. So here I'm going to plug in 1 over x. So I have 1 over 1 over x. Can't leave a fraction in a fraction. Remember, that's 1 divided by 1 over x. We don't divide by fractions. We multiply by the reciprocal. The reciprocal of x over 1 is x. So on that, we just get x. So f of x is x. Once again, you might be saying the domain is all real numbers because there's no restrictions. But remember, we simplified it. It wants to look like this. So x cannot be 0. So my domain is negative infinity to 0 union 0 to infinity. All right, the very last one, f of g of x. F of g of x, which is the square root of x minus 1. Plug that into f. 1 over the square root of x minus 1. That was f of g of x. Are there any restrictions? Yes, there's a square root in the denominator. The argument has to be greater than 0, so x has to be greater than 1. So my domain is parentheses 1, comma, infinity. Okay, once again, notice it says that in most cases, f of g of x and g of f of x are not the same. We'll discover tomorrow when they are the same, but we want you to realize that it is a big difference between doing f of g of x, oops, right here, I forgot to box it, and g of f of x. You don't always get the same answer. Okay, that's it for today.